All right. So, hello and welcome everyone. I welcome all of you to this amazing platform of Tutee Learning. So, we are live right now. All right. So, I hope I'm audible. Okay. So, welcome back on this particular topic of vector algebra. So, as of the previous discussions on vector algebra, we have so far discussed about the dot product and the cross product things, right? So, in the last class, we were discussing about how we perform cross products of vectors, right? So in that we saw that the cross product of vector is basically defined as follows, that the magnitude of it is obtained as the magnitude of a vector, b vector, sine theta, and then with a multiplied with a unit vector which denotes the direction which is normal to the both the vectors, and that is out of plane. So this is what we have discussed, and we also saw that how we found out the direction of that particular direction of the cross product using the right hand rule, right? So these are all the things that we have so far discussed in our previous class, right? So if you are new to this particular platform, I would request all of you to please subscribe the channel and hit the bell icon so that whenever we are live, you get a direct notification. Now, in this particular channel, we are trying to help all the students who are currently in their class 11th or class 12th, and they are basically aiming for competitive examinations like JEE Mains, JEE Advanced, or many other engineering competitive examinations like WBJEE examination or BITSAT examination, right? So this particular channel, they will help you to cover all those particular topics, especially for the competitive examination. So just by sitting at the comfort of your house, you can attend these lectures live, and you can watch and clear your doubts, and also you can prepare for your upcoming examination. So with this, let's start. Hi Sudha, today I wrote an exam on vector algebra set. Great, great Sudha. All right, so let's discuss about the topics on cross product. So let us talk from where we finished off in our previous class. So So let's start discussing on the cross product thing. So in the cross product, we've analyzed that what is the geometrical interpretation of doing a cross product, right? And we also saw that how to find out the vector product in terms of the component, right? So today let us see how we can also use this vector product to analyze the geometry of a plane. So let's start our discussion on the vector normal to the plane of two vectors. Normal to the plane of two vectors. So generally we use cross product to find out any vector which is normal to the plane of the two vectors. So if I say that a vector and b vector are two non-zero are two non-parallel non-parallel vectors with with theta as the angle between them. Okay, as theta as the angle between the vectors. Therefore, what we have studied so far is that we have seen that a vector cross b vector is given as mod of a into mod of b times sine of theta multiplied with the n cap. So n cap denotes the direction of the vector, which is basically a unit vector in the direction normal to both the vectors, and it is out of plane. So this is what we have seen in our previous discussion. So therefore, what I'm more interested is to know that how can I find out the direction of any vector which is perpendicular to the plane or normal to the plane of these two vectors. So in that case, I just need to evaluate the n cap, which will be coming out as a vector cross b vector divided by a vector mod b vector mod and sine of theta. So if I divide by this particular parameter, I'm going to get the unit vector which is normal. So I will get the unit vector perpendicular to the plane of two vectors. Alright, so I got the unit vector which is perpendicular to the plane of the two vectors. Alright, so this is what we got the result. So by using this particular result of this unit vector which is perpendicular, so this is what, so if I have a plane like this where I have two vectors a vector and b vector, so therefore the normal to this plane is given by this n cap, which is the unit vector. Now, in order to find out any vector in this particular direction can be given just by multiplying the magnitude with this particular unit vector. So therefore, if I need to find out any general vector, any vector um, normal to the a vector and b vector, that can be given as is equals to the lambda times this n cap, where lambda denotes the magnitude of that particular any vector. So any vector which can be denoted with this particular notation. I hope this is clear to all of you. All right. So I hope this particular result is clear so that we can start to discuss about some questions now. Is this result clear to all of you? Hello. Is this result clear to all of you? Is this particular part clear? Is this part clear to all of you? Please let me know in the live chat. If you have any questions, you can let me know in the live chat so that we can discuss about the question and it will help you to understand with the basics part. Okay. So therefore, let's try to solve some questions on the following concepts. All right. So the question I'm going to take are from the previous year JEE Advanced problems, JEE Mains problems. And the questions are very standard questions, which I think that everyone should prepare or should practice in order to have a good understanding. Right. So the first question begins as it says that let a vector and b vector be the vectors of same magnitude such that I have my a vector plus b vector mod of it plus mod of a vector minus b vector and whole divided by mod of a vector plus b vector minus mod of a vector minus b vector is equals to root 2 minus 1. So then you have to find out the value for a vector plus b vector mod of this square whole divided by mod of a vector square. So if you tell me that what will be the result for this question. So please try to solve this problem, a very interesting problem. So let's try to solve this problem. So it is said that they are the two vectors of equal magnitude. So there are two vectors of equal magnitude and given with this particular relation. So here you have to apply some relations of ratio and proportions and in order to obtain the final result. So please try to solve this problem so that we can discuss about this. All right. So please try to solve this problem. Hi, Ayush. Yes, please try to solve this problem. You have some time. Take your time and try to evaluate this question. Yes, sure. Sure. Take your time and solve this problem, Ayush. So if you look at this problem, it's a fairly simple problem. So let's try to see how we can solve this problem. So, so let's try to see how we can solve this problem. So it is first of all mentioned that I have two vectors, A vector and B vectors are the vectors of same magnitude. So what does this particular thing implies? That if I have mod of A is equals to mod of B, and let's consider this as lambda. Now, the interesting part is that we have already seen the magnitude of A vector plus B vector, which was simply given as square root of mod of A square plus mod of B square plus 2 times of mod of A mod of B multiplied with cosine of theta, right? So therefore, if I apply over here, so if I apply this result, now we know that mod of A and mod of B are same. So therefore, I will get the result as, so 2 times of, so I can take 2 plus 2 times of cos of theta and square root of that, and mod of A will come out of the square root, and this will be, so we have assumed mod of A as lambda, so let's write lambda over here. So this will, we can apply the theorem again. The 1 plus cosine theta will be 2 times sine square, 2 times cosine square theta by 2. So this result will be 2 times theta by 2 into lambda, right? Similarly, if we evaluate the value for magnitude of A vector minus B vector, it will turn out to be 2 times of sine of theta by 2 into lambda. So now if I look at the ratio over here, the ratio given over here, and now interestingly, in this particular ratio, if I apply the componendo and dividendo rule, so if I apply I hope you remember this from your junior classes, so componendo and dividendo. All right. So if I apply the component and dividend rule from here, I will have mod of A vector divided by A vector plus B vector divided by mod of divided by A vector minus B vector mod of it. And this will be equals to root 2 plus 2 by 2. Sorry, by root 2, right? Yes. So now, I can further simplify this particular values by putting into this expression over here, and this will turn out to be a simplified expression. So what I will see is that mod of A vector plus B vector is equals to mod of A vector plus B vector is equals to, or square of it is equals to 3 plus 2 root 2, 3 plus 2 root 2 times mod of A vector minus B vector and whole square. So over here, and we already know the formula, so I can remove that whole square thing and I can evaluate the formula itself. So from there, if you evaluate, the interesting result you will be trying to get is that you will get the result of A vector dot B vector divided by divided by mod of A vector whole square, that will turn out to be 1 upon root 2. So if you just simplify this particular expression, you will get this result. So from this particular expression, you can simplify and get to the result. Now, from here, we need to evaluate. So we need to evaluate mod of A vector plus B vector whole square divided by mod of A square. So this will turn out to be 1 plus. So we have seen that mod of A vector plus B vector whole square, and if I evaluate this expression, this will be mod of A whole square plus mod of B whole square plus 2 times of A dot B. So that can be divided by mod of A square, and the result is follows. So it is mod of B square by mod of A square plus 2 times of A vector dot B vector divided by A vector. So if I just now evaluate this, now we know that A vector and B vector have the same magnitude. So this is going to be 1. So this is 2 plus 2 times of 1 upon root 2. So this I can evaluate, and the final result is going to be 2 plus root 2. So I hope you are able to get to this answer. If you teach in Hindi, we will understand more. Sure, I will try my best to keep on incorporating the Hindi. Okay. So whenever you are not able to understand, just let me know so that I can repeat that part in Hindi. Is it clear? समझ में आता है आयुष? जहाँ पे जो चीज क्लियर नहीं हो रहा है, राइट, वो मेरे को एक बार बता दो, so that I can repeat that part in Hindi. Okay. But the lectures will be mostly in English only. Okay. बिकॉज इफ यू ट्राई टू, अगर अभी से अब तुम लोग प्रैक्टिस करते हो इंग्लिश में ये लेक्चर्स करना, तो बाद में जब आईआईटी क्वालिफाई करके आईआईटी में जाओगे, राइट, सो जनरली आईआईटी में सिस्टम ये है कि यहाँ पे इंग्लिश में एजुकेशन होता है, राइट, सो दे वोंट टेल यू टीच यू द थिंग्स इन हिंदी, और तुम अगर प्रोफेसर्स को ऐसे बोल भी नहीं सकते हो, राइट, कि मुझे समझ में नहीं आ रहा तो मुझे हिंदी में बताओ, ऑलराइट, सो यू हैव टू टेक दैट पर्टिकुलर अंडरस्टैंडिंग, ठीक है, तो अभी से थोड़ा प्रैक्टिस डालो तो आगे जाके यूनिवर्सिटी में काफी काम आएगा, राइट. It is not like they won't repeat it, they will definitely repeat it, but the general teaching is done in English only. Okay, so it is better if you get an understanding कि जब मैं English में पढ़ा रहा हूँ, so try to take the best out of it. Okay, and also this Hindi is not accessible for all other people, right? For example, students from West Bengal, they are not so good in Hindi, right? Or students from Chennai or southern part of India, right, they are not also not that good in Hindi, so I have to sometime take this in English as well. So to keep everyone in the viewpoint, I would teach in generally in English. Okay, I hope you will respect my decision and you will try to follow with it. Okay, is that clear? I think I have given a comprehensive answer to this your question. All right, so I hope this part is clear. So now, we can try to move to the solving some other questions. So let's try to solve a very important question, and I feel that these types of questions every student must finish to solve or should solve in order to understand the questions on vector equations. So let's try to see the question. So the question says that let the angle theta, let the angle theta be given as between 0 to pi by 2, and that particular angle is between two unit vectors, which is given as a cap and b cap. So they are between two unit vectors a cap and b cap, and that angle is given as sine inverse of root 65 upon 9, sine inverse of root 65 upon 9. And if the vector c denote is given as 3 times of a cap plus 6 times of b cap plus 9 times of a cap cross b cap, all right, then you have to evaluate then the value of then you have to evaluate the value of 9 times of c dot a cap minus 3 times of c vector dot b cap. So this is what the question is. So please try to solve this problem. So these kinds of questions are basically questions where you see that a random vector or any variable vector is defined by some vector equations of these two unit vectors, a vector and b vector, right? So please try to evaluate this particular expression. Okay. So please try to solve or evaluate this expression so that you're able to understand these kinds of questions. All right. Please try to solve this problem. Please try to solve this problem. Please try to solve this problem so that you can understand or at least give a try so that to have a feel that how you actually solve questions on vector equations. So once you're not able to, or maybe you're stuck in a part, I will be telling that particular part or how to evaluate that particular part so that the next time when you solve these kinds of problems, you won't actually feel any difficulty. All right. So there are certain standard method to solve these kinds of problems. So let's just try to evaluate that, right? But before that, I want all of you to please try over it so that if you are stuck in any part, we can discuss over it. All right. So please try. So please try. Please try to solve this problem. All right. So let us try to see how to evaluate these kinds of problems. So first of all, we have two unit vectors given to us. Now, the most important catch to solve these kinds of problems over here is by to evaluate how to evaluate this particular vector equations. So if we look at this particular vector equation, that is my C vector is given as 3 times of A cap plus 6 times of B cap plus 9 times of A cap cross B cap. Now, the difficult part to evaluate this particular expression is this particular part. So if any means I'm able to remove this particular part from my expression of C vector, then it will be very easy. So what I'm going to do is that it's a very important step to understand is that we will try to take a dot product with A vector on both the sides. So if I do that, I'm going to end up getting this particular result as follows plus 0. So if I take a dot product with this cross product, we know that A cap cross B cap, that is perpendicular to A and B. So this particular thing, when I take the dot product with the A vector, it is going to give me 0. So over here, I can simplify and C vector dot A cap. So I should be writing in A cap is going to give me 3 plus 6 times of A cap dot B cap. Now we can evaluate this particular expression because we also already know the value for the angle between the vectors. And similarly, if I take the dot product with the B cap or B cap over here, the result is going to be 3 times of A cap dot B cap plus 6 times of mod of B cap square, and that is going to be 3 times of A cap dot B cap plus 6. So I have two equations in my hand. So I have evaluated what is A cap, C vector dot A cap and C vector dot B cap. So I can just replace it over here, and the expression that I need to evaluate is finally 9 times 3 plus 6 times of A cap dot B cap minus 3 times of 3 times of 3 times of A cap dot B cap plus of 6. So this is what I have to evaluate. Now I know that A cap dot B cap is equal to mod of A cap mod of B cap into cosine of theta. Now we know these are unit vectors, so this will be result is only equal to cosine of theta, right? And we have seen that the angle between the vector is given as sine inverse of root 65 upon 9. So the interesting part over here, from here we have to calculate what is cosine theta. So the cosine theta value will be 1 square root of 1 minus sine square theta, and that will turn out to be this particular result. So which I can evaluate, and this result of cosine theta will come out to be 16 upon 81, and square root of that, which is nothing but 4 upon 9. So the result is going to be equals to 4 upon 9. So I have the result as 4 upon 9, so which I can directly plug over here, and I can evaluate this expression. So all right, so if I just solve this expression and I solve this part, so I'm going to get the result as equals to 29. So 29 is going to be the final result. So I hope this is clear to all of you. Are you all able to get to the solution? Are you all able to get to the solution? Is this part clear to all of you? Is this part clear? Is this part clear to all of you, so that we can discuss about some more other important questions? But these parts need to be first clear, right? So that when I give you any other general type of questions, you can take up, right? All right. So I hope this question is clear. So let's now move to another important problem. And this is also a very interesting problem. This question says that we have a vector given as 2I cap minus j cap plus 3k cap. My b vector, my b vector is given as 3I cap minus 5j cap plus k cap, and c be a vector which is given as a vector cross c vector is equals to a vector cross b vector, and that is equals to c vector cross b vector. So c vector is such a vector which is given by this following relation, and you also have a relation, that is a vector plus c vector mod of b vector plus c vector is equals to 168. So based on this relation, find the maximum find the maximum value of mod of c whole square. So find the maximum value from this particular result. So from this result, try to find out that what will be the maximum value of mod of c square. So from this result, try to find out the maximum value of mod of c square. So that is an question, right? So this is a very interesting problem, and to solve this question, you actually need to have certain basic understanding regarding the how to evaluate this particular expression, and then the question is straightforward. So let's try to see how you will evaluate these kinds of problems. So in order to evaluate in order to evaluate these kinds of solutions, so if I look at this particular expression over here, so I'm going to use this particular expression. So if I look at this expression over here, and I can write the same expression by taking this part on the left hand side, and is equals to, and this is an unity, right? This is an identity or identical equation, and is equals to 0. So therefore I can take a vector common, and a cross c minus b vector is equals to 0, or 0 vector. So what does we mean when we take the cross product and come out to be 0 vector? That basically means that these two vectors are parallel. So I can write over here that a vector is parallel to b vector minus c vector. So from here, if I am to write to c vector, then it will turn out to be some constant multiple of b vector plus, so, or um, maybe from this particular expression as well. So if you try to evaluate this particular expression as well, other equation, so I can take a vector minus c vector and cross of b vector to be 0 vector. So which is again meaning that b vector is parallel to a vector minus c vector, right? So from here I can also represent B vector as some other multiple of A vector minus C vector, right? So therefore, combined over here now, and if I compare this equation and this part, then I will get a relation that is A plus B vector cross C vector is equal to 0 vector, which means that C vector is parallel to A vector plus B vector. So from this result or this expression, I can evaluate that C vector is equals to some lambda times, so some lambda times of A vector plus B vector, right? So from here, now if I try to evaluate the mod of C vector, it will come out, or maybe square of mod of C vector, it will come out as lambda square times 25 plus 36 plus 16, and that will be nothing but 77 lambda square, right? So the only part is to evaluate the value of lambda or the maximum value of lambda to get the maximum value of mod of C square. So if I do, how do I find it? I will find out by doing this particular expression. So over here in this particular expression, it is A vector dot B vector plus A vector dot C vector plus C vector dot B vector plus mod of C square is equals to 168, right? So if I'm just expanding this relation and I'm putting in the values, so this particular value of C vector dot A vector plus B vector will turn out to be, will I'll just carry out in the next few lines over here. So if I just do that expression, it will come out to be, so A vector dot B vector is 14, and this C vector dot A vector plus B vector plus 77 mod of, so we have already found out the mod, that is 77 times mod lambda square is equals to 168. So from this equation, or if I just do it, and we have already seen the lambda C vector is given as lambda times A vector plus B vector, which is 5 I cap minus 6 j cap plus 4 k cap, right? So from this expression, if I do this over here, I will have another equation in lambda, and the final equation will stand out as 77 lambda plus 77 lambda square minus 154 is equal to 0, which I can simplify because 77 times 2 is 154. So this result will be lambda square plus lambda minus 2 equals to 0. So this is my final quadratic equation in lambda, which will have two values. Either it will be 1 or minus 2. So either it will be 1 or minus 2. So from here, what I can comment is that the maximum value of lambda square will be obtained when I put as my value of lambda as minus 2, and it will be 77 times 4, which is equals to 308. So this is going to be the final result. I hope this is clear to all of you. Okay, is this part clear? So with this part, let's conclude our discussion for today's class, where we have discussed how to solve different types of problems for vector algebra on cross product and dot products. So in the next class, we're going to start our discussion where we're going to analyze the vector products of three vectors, like the scalar triple product and the vector triple product. So with that, we'll be coming to the end of our vector algebra, and simultaneously we can start discussing our parts regarding 3D geometry. So vectors and 3D geometry is going to be very, very important, especially if you're looking for your IIT JEE examination. So for JEE Mains and JEE Advanced, your vectors and 3D geometry is going to be very, very important, and it has a very high weightage as well. So preparing those particular topics very from the basics is going to be help you a lot in solving questions. So please take that particular point of, and please keep on doing a revision on this particular topic. And again, if you're new to this particular platform, please subscribe to the channel and also hit the bell icon, so that whenever we are live with this particular discussion, you can attend or join our lectures. Okay. So with this, thanks a lot for joining the session. Again, we're going to have a session tomorrow. We're going to start with the discussion of scalar triple product. So till then, okay, bye, and I wish you all the best.